All right, let's pull back the curtain on the AI revolution. Today, we're doing a strategic briefing on the hidden infrastructure that actually makes it all run. We're not talking about algorithms. We're talking about the physical hardware that moves all that data at the speed of light.
So let me ask you a question. What's the biggest thing holding AI back right now? You're probably thinking GPUs, right? Raw compute power. But what if I told you the real bottleneck isn't how fast we can process the information, but how fast we can move it around?
The answer is light. Yep, the true limitation today is data transmission. These massive AI models are so incredibly data hungry that the problem has shifted from compute to communication. And this is the starting point for our entire analysis today, the race to build the optical backbone for AI.
Okay, so here's how we're going to break this down. We've got 6 sections. We'll start with that hidden bottleneck, then introduce the magic material that's solving it. We'll look at the clash of the titans in the industry, and then zero in on Taiwan's critical role as the world's photonics foundry. After that, we'll expose a huge geopolitical choke point before giving you our final verdict.
So, Section 1, AI's hidden bottleneck. We're in the middle of a massive shift. For years, everything was compute-bound. It was all about how fast your processor was. But with large language models, you have thousands of GPUs that need to act like one giant brain. And now the whole system is I/O-bound. It's all about how fast you can get data in and out.
To really get it, you got to think in 3 dimensions. First is scale up. That's connecting all the GPUs inside one server. Then there's scale out, connecting all those servers to each other. This is the sweet spot right here, driving absolutely insane demand for 800G and 1.6 terabit optics. And finally, you have scale across, linking entire data centers together. At every single one of these levels, old-school copper wires just can't keep up. It has to be fiber optics. And if you want to see just how insane the demand is, look at this. This is just from one customer, NVIDIA. They're projected to go from needing about 120,000 of these high-speed modules late this year to over 1 million just 6 months later. 1 million. That's not growth. That's an explosion. The entire supply chain is feeling the pressure. Which brings us to our second section, and really the hero of this story, the material that makes all of this high-speed light possible. It's a compound semiconductor called indium phosphide, or InP.
So what the heck is indium phosphide, or as it's called in Taiwan, Lin Huayan? Well, its magic comes from a physics thing called a direct band gap. Now, you don't need a PhD, just know this. Silicon is great for thinking, but it's terrible at creating light. In IP, on the other hand, is a natural. It was bone that turned electricity into photons. Every silicon photonics chip you hear about still needs an external laser made from an IP to actually create the light in the first place.
So let's be super clear why InCarp is the only game in town for AI. First, that direct band gap means it can make lasers. Silicon can't. End of story. Second, its electrons move incredibly fast, which lets it operate at the mind-bending speeds needed for 800G and beyond. And third, it handles heat really well, which is absolutely crucial for cutting down on power and cooling bills in these super-dense, super-hot AI data centers. Now, when you have this kind of explosive demand for a critical material, you know what happens next, right? A fight. Which brings us to Section 3, the clash of the titans. We're talking about the 2 US giants that basically own the global market for this stuff, Lumentum and Coherent.
And this is where it gets fascinating. These 2 companies are taking completely opposite paths to win. Lumentum is running a virtual IDM model. They focus on designing the best tech, the core IP, and then they outsource the heavy lifting, the manufacturing, to what we're calling shadow factories in Taiwan. On the other side, you've got Coherent. They are all in on vertical integration. They're taking CHIPS Act money to build their own massive factories in the US and Europe because they want to control everything from start to finish.
This split in strategy puts a giant spotlight right on our 4th section, Taiwan, the photonics foundry. And we're not just talking about a few random suppliers. We're talking about a deeply connected ecosystem that has become the indispensable engine room for the entire global industry.
At the very heart of Lumentum's strategy is a company called Landmark. You have to understand they're not just some vendor. They are Lumentum's absolute core partner for epitaxy. That's the super complex process of growing the material on the wafer. Landmark is Lumentum's primary shadow factory. So when Lumentum gets a huge order from Google or NVIDIA, that translates directly into huge orders for Landmark.
And then you've got Win Semi. These guys are already a giant in the world of radio frequency chips for your phone. But now they are pivoting hard into optics. They're the key partner for the other side of the connection, the high-speed detectors that catch the light.
With their enormous scale and manufacturing know-how, Win Semi is a sleeping giant in this space.
And the ecosystem is deep. You've also got players like VPEC, providing crucial backup and supply chain security. There's GCS, a specialty shop making the ultra-fast electronics that drive the lasers. And then there's IntelliEpi, the precision specialist, using a different kind of technology for the absolute highest performance parts.
And this table shows the key difference. Most of the big players like Landmark use a process called MOCVD. Think of it like a big batch oven. It's fantastic for cranking out tons of lasers. But IntelliEpi uses a technique called MBE. That's more like 3D printing, atom by atom. It's slower, it's more expensive, but the precision is just on another level. You need it for the next generation stuff.
But, and this is a huge but, this entire amazing ecosystem is built on a very fragile foundation. And that brings us to Section 5, the geopolitical choke point. It all comes down to the supply of the raw material.
Just look at where the raw wafers, the substrates, come from. It's an oligopoly. You have two Japanese companies, Sumitomo and JX Metals, and one company, AXT. They're headquartered in the US, but they do all of their manufacturing in China. You can probably see where this is going.
And here's the lever. Just this year, China slapped strict export controls on gallium and indium, the key ingredients for INP. This means AXT, with its factories in China, now needs to get a permission slip from the Chinese government for every single order it ships. That's a massive amount of uncertainty and risk in a supply chain that needs to move at lightning speed.
And this risk doesn't hit everyone the same way. This matrix tells the story. Win Semi buys on the spot market, so they are highly exposed. In fact, their shipments have reportedly been deprioritized. But Landmark, wow, they showed incredible foresight. They locked in a multi-year supply deal, protecting them and their main customer, Lumentum, from all this short-term chaos. That's a huge strategic advantage.
Okay, let's bring it all home in our final section, the verdict and what the future looks like. We've covered the demand, the material, the corporate strategies, the Taiwan ecosystem, and the geopolitical risks. So, what happens next?
Well, this race is only getting faster. We're in the middle of the 800G ramp-up right now. By late 2025, we're already moving to 1.6T, which needs even better tech. And looking out a few years, the industry is moving to co-packaged optics, CPO, which basically means putting the lasers right on the GPU package. That's going to create a whole new wave of demand. The pace is just relentless. So, our final verdict. Lumentum is the big customer driving demand, and their success is completely tied to their partners in Taiwan. Coherent is the big long-term competitor, building their own supply chain, but for now, they're still a customer of Taiwan's ecosystem too. Within Taiwan, Landmark is the alpha play. They have the key customer and the secure supply chain. And Win Semi? They are the sleeping giant. They have short-term risks, but if they solve their supply issues, their scale could let them dominate.
So let's end on this thought. The AI arms race is being fought with light. The world's tech giants are busy designing the weapons, but the real question is, can they secure the ammunition? And as we've seen today, the answer to that question isn't in Silicon Valley. It's being forged in the photonics foundries of Taiwan.